Once again, hello everybody, welcome to our webinar. I'm really happy to see that we have great attention today. And okay, we will do our best to take you something, that you take something away with you from this webinar. Hopefully we can answer more questions when leaving things open. And I have to say it's somehow a premiere today. Well, it is for the first
Yes.
time that PARIFEX and Velodyne do a joint webinar together.
So please be nice with us.
Why do we that? Very simple. PARIFEX is amongst most experienced integrators, and I can only say that they are spearheading advanced use of 3D LiDAR within the traffic application segment. So if you will leave this webinar with a good feeling, in that sense, that we could have made you curious about using the kind of applications and sensors we are not talking about, then I think we have reached our goal. Well, if I say we, who are we? Today, you have two hosts in your webinar. My name is Dieter Gabriel, and I'm with Velodyne as Marketing Manager for the EMEA region. And your other host today is the highly esteemed Nathalie. Nathalie,
yes.
you introduce please yourself.
Sure. So my name is Nathalie Deguen. I'm Sales Manager of the Speed Enforcement Department at PARIFEX. So I'm in charge of international sales development and also the diversification of our activities. I'm happy to be here today to talk more about the applications.
Okay, thank you. So, and we do have an agenda. We are going to present today to you following. First, we want to start with a short overview on Velodyne Lidar and PARIFEX, and you will see a short introduction in the service offering portfolio, product offering portfolio from PARIFEX. And let us talk a bit about the role that 3D LiDAR plays in traffic-related applications. And I'd like to stress a bit the use of LiDAR sensors for what we are talking about. And the biggest part, the most important part of this webinar shall cover use case examples like speed measurement, traffic management, smart infrastructures, and even whole smart city applications. And we like to conclude with a question and answer section. So don't worry, we look to keep the webinar short. And one remark regarding the questions. So as you may have noticed, you cannot interact verbally. You will have, as webinar attendee, no access to the response function via audio. So please use the chat functionality to share your questions. And I promise you, we will have enough time at the end of the webinar. So don't worry, we want to keep the webinar short, let's say around 35 minutes from now. So at the end, you will definitely have time to get your questions answered. And by the way, in case you have questions about our LiDAR applications, they may come up during the webinar if you want to know more about specific use cases, which we may not cover directly with this webinar. So you're welcome anytime to contact us, that we can individually follow up with you. Okay, to begin, let me please say a few words about Velodyne. No worries again, I will keep it short. We've been around for quite a long time now. Our founder and owner, David Hall, invented real-time surround view LiDARs back in 2005. At that time, as part still of Velodyne Acoustics, and since then, a great success story developed. We started commercial production back in 2007, and we are indeed proud of where we are today. We have an incredible number of customers globally. We are working with most major automotive OEMs and as well in a huge variety of emerging technology sectors. And you see our global presence. For my part, I'm just talking from our Europe office near Frankfurt right now. So we have an advanced research center in Alameda. We have our global headquarters located in San Jose. We are close to Frankfurt in Germany, and we are serving the Asian market, the APAC territory from Beijing in China. So Our company has been inventing, producing, and testing state-of-the-art sensors for more than 13 years meanwhile. And with our current full suite of LiDAR sensor products, we do much more than automotive. And hey, which by the way sets us clearly apart from competition in the LiDAR market. Our portfolio of products addresses not only AV and ADAS applications, but also robotics, mapping, trucking, industrial equipment, machinery, UAVs and drones, agriculture, security, and last but not least, traffic and smart cities. So, and let me hand over to Nathalie. So, Nathalie, it's your turn now, please.
Sure.
I will stop my screen.
Stop the screen, yeah.
So it's your part,
Okay.
please.
All right. Here we are. Okay, so quick overview about PARIFEX now. So we are a French company. You might recognize the accent. Sorry about that. We established in 1994. We are organized in several divisions. The first one is engineering, so mainly in automation and control system fields for the oil and gas industry to other industries. The second one is, which is actually my subject, is speed enforcement. So we actually are one of the main providers for the government of speed traps. We develop, design, and manufacture our own equipments. Currently, we have about 400 equipments deployed all over France. 200 additional ones are to be installed by the end of this year, if everything goes well. And we actually have been awarded a new contract for the government again for about 1,000 units of urban speed traps. So those ones are going to be installed by the beginning of 2021. So all this contract means an important growth for us, obviously. So last year we made 16 million as a turnover, which is quite nice for a small company as us. And we've made a big hiring plan for this year. So we will reach a number of 6 employees. And for these contracts, we did a lot of developments in AI and sensing. We have a big R&D team here in PARIFEX. And all these developments led us to create a third division, which will be dedicated to city matters. So it's because we realized that all our solutions developed for speed enforcement could actually also fit for other applications, for smart city, for instance, for mobility, etc. I will go more into details after. Our head office is in France, obviously near Paris. We have offices in Asia, in Kuala Lumpur and Korea as well. And we have sales representatives in the Middle East region and Africa. So now getting into more details about that's what we do. The first one is, it's actually the historical stationary system that we have at PARIFEX. It's the one you see all over France in all our roads. It's the first one to discriminate trucks from passenger cars. So it makes the difference between different categories of vehicles. Second one, VG-DSI, so it's double side interception. So it's the evolution of the VG, and it takes 2 pictures of the same vehicle from the front and from the rear. So we get more offenses recorded, and the precision is more interesting. Third one, the nanocam, which is actually the subject of today. It's a multi-tool sensor. So as you see, it's equipped with a 3D LiDAR from Velodyne, obviously, which is integrated in our own housing. It's a version with or without camera. This one, why I say it's a multi-tool, it's because it can be used in different applications. It can be used as a portable speed trap or integrated in other systems, like actually it's the case for VG and VG-DSI, for which the 3D LiDAR is used for vehicle identification and classification, so it's integrated in the system. And it can also be used as data collection sensor. So I will go into more detail after. And the fourth one, the Nomad, so it's actually the system I was telling you about to be installed in 2021. It's a multi-violation control system. So this one is also equipped with 3D LiDAR. It monitors speed, red lights, stop signs, tailgating, seatbelt use, phone use, many violations, all made possible by the 3D LiDAR measurement. So now it's TV time. So I will show you a quick video to summarize all the functionalities that we are able to cover with our speed traps. So the VG, a very robust system. We have a lot of vandalism in France, so we've made our system very robust. So it's able to cover 4 lanes, make the difference between trucks and cars, as I said, but also other categories of vehicles, motorbikes, coaches, bicycles. Evolutions, as I said, 2 sides. So 1 picture from the front and from the rear. And as you see, the vehicle...
Nathalie?
Yes.
We still see no other picture as the product range with the 4 products.
Sorry. Where's the video then? Hold on 1 second. Okay. Can you see it now?
No, not yet. Did you share your complete screen in order to avoid trouble?
No. Sorry for this.
What looks better?
Sorry. So I'm not going to start again. It's going to be too long, but I was showing the VG, the functionalities that he would cover, multi-lane monitoring, the VG double side. So 2 pictures, and you see the vehicle changes lane. And even with that, the picture is still taken. It's thanks to the 3D LiDAR that acts as a trigger for the camera. So we monitor tailgating, so, the nanocam. So we monitor both directions. We can install the system on the side of the road or on top of a bridge. This is all the information we might get on each target. So we know the precise time, the category, the speed, the location. This is one of the applications I will tell you more about for driverless shuttles. So we are able to detect all the targets in the field of view and communicate this information to him. So it will help him in its trajectory. The latest one that does multi-violation monitoring. So we monitor the speed enforcement, red light enforcement, simultaneously. Different kind of street lights. This is right-of-way violation. Basically, any violation that is written in the driving code. Stop signs. And these are the pictures we get. So we basically always take 2 pictures. Reserved lanes, so shouldn't be driving on this one. Is the summary. So back to my slide. So now getting really into today's subject, the 3D LiDAR technology. So I will let Dieter talk about it better than me. Basically what I can say is What is 3D LiDAR? It's layers of laser beams that rotate at 360 degrees, retrieving a point cloud. Each point with its Cartesian coordinates, and it allows a 3D modeling of the environment. So it's a very powerful technology that's often used for mapping, but we used it for our application. I will show you a quick video. Do you see it?
Yes, it works.
It works great. So it's just quickly to show you what the LiDAR sees. So this one is a Velodyne VLP32. So it has 32 beams. And you see the environment very precisely. So this is near our office. It was a bit cloudy that day, as often. And you see clearly the environment, the vehicles driving. I think if I go further this way, you see the signs, the shape of the roundabouts. So it's very precise.
Okay.
So I let Dieter continue.
Yes, thank you. So you close your screen share, please.
Yes.
Cool. Okay. So, and I go back to my one. Okay, so after this short glimpse on what PARIFEX can do also with LiDAR, before we delve into the actual applications, I would like to highlight a few things about how LiDAR works, how LiDAR contributes to this kind of applications, and what's the overall benefit of LiDAR. So, and since we have an audience with different state of knowledge about this technology, just a few words about it. So each of you should be aware this technology uses eye-safe laser beams, and we can somehow depict in 3D the environment. But let's talk about in more detail about it. A multi-channel LiDAR scans its environment with billions of photos per second at 360 degrees in order to completely see the surrounding world, whereby it highlights objects and makes them recognizable and shows movement. So this is the most important basics to understand about the systems. So you see it a bit highlighted here. LiDAR can handle object recognition of both non-stationary and stationary objects, and the latter is clearly a shortcoming of radar, by the way. LiDAR, as its own light source, can even see at night. And allow me a few words regarding cameras versus LiDAR. Cameras depict the world usually in 2D, means they give us a flat representation of the environment. After all, our LiDAR represents the world in true 3D, showing it as it is. Cameras fall short in dealing with critical light conditions. They lack the capability for instant object measurement. They require much more computer power for advanced evaluations. We are affected by problems with lighting conditions. It can be ambient light, it can be sunlight influence. You may have heard about the effect that while relying just on camera, you may not see a whole truck because it's enlightened, it is a bright object. This will never happen when you use LiDAR. But while combining both sources, camera and LiDAR, you get together a great team. One more example to illustrate what LiDAR contributes to a suite of sensors. Here you see the car on the left, which is equipped with radar and camera only. It still has blind spots. While the car on the right, issues. While with the car here, we have no issues with blind spots or also with angle hazards. That's not existing anymore. And one important point, think about how LiDAR is superior to radar. It can accurately identify objects of up to 250 meters or beyond, while even high-resolution radar cannot render objects accurately there due to a much poorer resolution. And even more, radar can have problems with stationary objects. Please keep that in mind. So from Nathalie, before you've seen already an example of our Ultra Puck with 32 channels. And now I like you to show one more data example, one more derived from our latest Alpha Prime sensor. And the Alpha Prime is the optimal long-range sensor. It's a sensor providing long-range detection of low reflectance objects. The Alpha Prime enables a lot of applications, not least in urban environments, clearly addressing more than the automotive vehicles market. And have a look, compare it with the resolution you've seen before. Oh, that's one of my favorite here when we pass the truck. And when we leave a highway, go into an urban environment, you see the richness, how the sensor can depict the environment. That's amazing. So, as mentioned before, we have a full range of sensors that enable a lot of great applications within traffic monitoring and smart city applications. And I don't want to delve too much into details here anymore. So if you have questions, if you want to know more about our full set of sensors from directional lasers like the Velodyne or the rotational lidars, please do not hesitate to contact us at any time. And now I would like to hand over to Nathalie again so that we can highlight a bit more the different use case examples. Nathalie?
Sure. You need to, okay, my turn. So Dieter explained all the fantastic skills that 3D LiDARs offers. Indeed, it's quite amazing, we've noticed. So we decided to use all these fantastic skills to do traffic data collection. So we developed our own algorithm integrated into our own system that allows to detect all the moving targets in its field of view. So vehicle, pedestrian, animals, whatever you've seen on the videos. And for each target, we collect all the following info. So we have the ID of the object, the precise dimension, so that gives us the category of vehicle. So we have the classification of the object, pedestrian, bicycles, vehicles, trucks, etc. We have the position of the object relative to the sensor, so X, Y, Z, the direction of movement, the speed, the acceleration, the timestamp, etc. So all this information, with all this, we can provide real-time data for traffic management or traffic counting. So I'll show you quickly how the data looks through our software. So you see the video, right? Dieter?
We see it.
It works?
Yeah, it works well.
I'm not sure now.
No, it's wonderful.
Okay, so on the left, you have the LiDAR view, it's the bird view with all the vehicle being counted. And on the right, you see what the displays and all the information you can have for statistics and traffic management. So you can have, I'll go quicker. Here you are, all the information. So you have the vehicle flow rate, it could be per lane or per total, so the number of vehicles that you've done, the occupation rate, the harmonic speed, you have the category of vehicles, the lengths, etc. And you can have live displays. So indeed, all these data are recorded in real time and treated in real time. So you can have live display or pick a precise spot for a certain period of time on the toolbar on top. So either you have those statistics in live, or you can also download an Excel report at the end if you want. So this sensor is actually in operation in France, as it's integrated in our speed trap cabinets. We are certified for vehicle identification and classification with the 3D LiDAR. And for your information, we're currently in the process of certification for the speed using the 3D LiDAR. So it's going to be soon certified. So as you see, we use the LiDAR for identifying the vehicle on the picture. And also for vehicle classification, you see precisely the profile of the vehicles, and you have the precise dimension, helping us to deduce the category of vehicles. Another possible application I want to tell you about is for driverless vehicles. So you've seen it on the presentation video quickly. For driverless vehicle projects, they require smart infrastructure to communicate with the shuttle. So we are currently on an experimentation project led by Transdev, where they asked us to monitor roundabouts. We install several systems to cover the area, and we do a fusion of the point cloud. And so the area we cover is way more important this way. So this functionality is very important for the vehicles as it prevents blind spots. Dieter mentioned about it. You know, on roundabouts, there are often trees or work of art in the middle, so the driverless shuttle can't see everything. So our sensors tell the vehicles what they might not see, meaning, for example, a pedestrian crossing, a vehicle arriving too quickly, etc. And this way, with this information, the autonomous vehicle would adapt its speed or trajectory accordingly. So let me show you again another example of, so this is an example of our system in operation. On the right, we just put a camera view to help you understand and compare with what's happening on the left side. So left side is the bird view of what is recorded by the sensor. So in this case, I think it's again a VLP32 by Velodyne and operated with our software. So you see, detect all the cars and put a bounding box and an ID, and we can track them. So the sensor in this case is positioned here on the tripod. That's why it's quite low, you see on the camera. And we can cover all this area. So you have the category of vehicle. In this case, it's mostly cars, but I think at some point here we see a pedestrian, some point here. So you can't see on the camera yet, as it's not on the field of view yet, but it's gonna appear here, I think, here. So this is just to give you an idea of how the system works and how we detect all these vehicles. And again, we've talked about it already, but knowing that we can detect all these targets and have all this information allows us to do traffic flow management and traffic counting. So it's quite efficient for this kind of application. Now, why the 3D LiDAR compared to other technology? So we know actually the Doppler radar technology, we know it very well because we started with it. But we decided to switch to 3D LiDAR because of all these advantages. So you see the accuracy is way better, the precision in object detection, as Dieter mentioned, is way more interesting. The range also the fact that it works in any weather conditions, it's not affected by day or night, and combined with our algorithm, that give us very high accuracy in object detection, counting, positioning, and tracking, object classification, obviously, and all this in real time. I don't know, Dieter, if you want to add something at this point, or I switch to the last one.
Well, for us, it is important that none of the sensors you list here actually works satisfyingly well as standalone system. So it's always a combination of few sensors that gives you the real value. And with regard to decide what is the ideal sensor set, LiDAR always plays a crucial role. And you see, I'm happy to hear from your user experience that you are even able to skip radar here, that you can try to or decided to avoid radar, and you do all your evaluations, run all your applications just by combination of LiDAR and video. And I think this is a real proof of how ideally LiDAR contributes together with video in a way that you clearly can depict the environment and the objects. And at the end of the day, it's about the behavior in the rate that you have clear, good, reliable object detection in the far range, that you get good reflectivity values under critical circumstances, and that you can operate the whole system reliably under all different environmental weather conditions. That's great.
Yeah. So you mentioned what is also interesting is the combination of the two technologies. You see the 3D LiDARs as mostly plus signs. The only minus point I would say would be to read signs and see colors. So that's what we did, because the good thing is we also have expertise in image processing. So we decided to combine these two technologies, LiDAR and camera, to have this new system, the Nomad, so the one I was telling you about. So the combination of this technology gives us this system that is able to cover all these violations. So red light enforcement, speed enforcement, stop sign, reserve lanes, pedestrian priorities, tailgating, seatbelt use, phone use. So all these are done with the combination of the LiDAR and the image and the camera with image processing. You see.
And by the way, you mentioned some shortcomings, some demand for further improvement regarding color detection. And so this is something for the midterm. We have something in the loop, and we are working on colorized representation using LiDAR as well. So I think we're in a good way with that.
On the video, just to show you how the system works for red light detection. So it's actually completely non-intrusive. It doesn't have to be connected to the street light. As you see, it's the camera that detects the status of the lights. In this example, we've shown that the vehicles are detected by image processing, but actually in the real system, it's still the LiDAR that does the vehicle detection. Only the street light detection is made by image processing. The last application I will tell you about is the ANPR. So we've made our own ANPR software. The interesting thing in that case is that we also use the LiDAR to make a pre-selection of the images. So the LiDAR detects the vehicle, and it also the plate. And after the plate is read by the image processing. So what's interesting is that it makes the treatment way quicker, as the flow of images to be treated is reduced, unless a classical system would analyze the complete flow of images. So we get the data quicker. Just a quick comparison between a conventional system and our system. So it's just obviously that if you can detect all the vehicles, the performances are higher. That's why it's interesting to have the classification functionality. And to conclude on my part, so these are all the possible applications we've been working on, but actually the possibilities are endless. Once you know that we can gather that many information in real time, we just need to use the data in different applications. It's really, there's many possibilities, and we just don't have the time yet to cover all the application. But so far, we've been working on driverless vehicle projects, traffic management, traffic regulation application, smart parking also. There are some very interesting cases. And obviously, this is our main activity, detection of offenses for enforcement. Back to you, Dieter.
Okay, thank you.
Stop.
Well, we are already through with our short excursion into the world of traffic applications. I only hope we could help a bit to increase your understanding about what is possible with solutions like the ones which we've addressed. So it's time for your question and answers now. Let's have a look at, and I see nothing yet. So what could this mean? We would be happy if that would mean that we exhaustively covered the whole topic. So could it be with no questions are left?
Yeah.
So I see somebody's raising his hand. So something's coming in. Hi, here we have a question.
Okay, so I guess it's for me. So far it will be for France, because all the certification organizations are mostly national, but it would meet the IOLM certification also. So it could be easily transferred to another certification for another country. I think we will have done the most difficult part.
Yeah, I think this is...
For which country that would be?
Pardon me?
I wanted to ask the Mr. Gallen.
General. This was for general interest. And I think this is widely important. Okay. This is really important.
Yeah.
That we get here a fully operational system that will be really certified. So this is a huge step forward for LiDAR as well, because we really officially to compete in that kind of applications with well-established technologies like radar, and we get a certification for it. That's great.
Yeah, true. And I may add that the certification system in France is, how do I say, very strict. So I think they would cover most countries also.
I just get a reminder from one of our participants who has sent some questions via email. Just a second to let me look it up. So, one question is about the ideal range of LiDAR for 3D perception. And we are being asked if this does depend on use cases like for object detection or traffic detection. At the end of the day, it depends on which sensor you are using. So we, for instance, have sensors covering a range from 100 meters up to 250 meters and more. And all our new sensors come with the capability to detect objects at the far range, at the maximum range, with at least 10% reflectivity on the target. So from that, with respect to that, you are in the safe side if you use, for instance, an Ultra PAC and PAC MR or the Alpha Prime that I showed before. So that means that you are capable to see in the maximum range. For instance, if you think about the Ultra PAC, within a range of 200 meters, you get enough reflectivity back from actually a dark object. So this is one of the really important benefits of using such a system for applications like the ones discussed. So let me look for other things. We have a question if LiDARs can be used for lane recognition. I have to say clearly Yes.
Yes.
Would you like to add something to that, Nathalie, from your experience?
No, but well, yes, clearly we use it for this kind of needs for our case in speed enforcement.
Mm-hmm.
So yeah, it's
So our kind of
worthwhile.
sensors, all these sensors which I introduced before, come with a feature we call calibrated effectivities, and you clearly can distinguish within the capability of the spatial resolution with the respective sensor offers to you, sorry, a lot of different surface capabilities. So you can clearly distinguish the black asphalt from the bright lane marking. You clearly get a signal, as we saw before in the video from the alpha prime. You get signals from reflective targets like traffic signs and so on. Maybe I try to get back. Wait a second. I try to get back to the Prime video. Where am I? It's better we show it on a nice example. So think about here. You see the lane markings in the middle. Oh, that's a bit too quick. Here, you see the markings, you see the traffic signs, you see the plates of the vehicles. Look, and here, this is very interesting. If we approach here the traffic signs at that point in the middle, you see they are turning from yellow to red. This means this is a highly reflective surface. And we have a question about the amount of processing time. So after collecting the data, we have a question if you as PARIFEX are involved in a lot of annotation, of classifying the data. Maybe you can answer this kind of question.
I'm not sure I got it, sorry.
So as far as my
Processing
understanding
time?
goes, you evaluate mainly real-time data. You are
Yeah,
not doing a kind of mapping job where you add additional evaluations to the data, do some
no,
classification,
yeah,
annotations, and that kind. So you can
it's real time.
simply run all these kind of applications you introduced us to as real-time.
Yeah,
That's a
exactly,
huge benefit of
correct.
the whole thing.
Yeah, 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 compared to other traditional systems that may request some time to analyze the data, we have all the information in real time in a very quick.
And I have a final question got in regarding calibration efforts. For our part, I can say Velodyne Lidar sensors come pre-calibrated by the factory, and all you have to do is that you do the right, when you take care for the right installation, when you combine the several sensors, when you adjust them, when you do the, actually you do the calibration in the sense that you combine it with your inertial navigation system, with your IMUs, if you use one, that all the sensors fit to the same level, that your lever arms are appropriately set up. With the sensor as such, you do not have to take care for any additional calibration work.
Yeah, I would say I cannot agree more, because that's one of the main advantages we saw also on the LiDAR as a system that doesn't need any additional calibration. Like for instance, portable solution one, you can basically just install it on the side of the road and you don't need to have any calibration.
I just saw another question, but it appeared that it vanished.
Yeah, I just answered it. So
okay, cool.
The gentleman asked if we could create a network of smart city units to track the same vehicle as it moves out of sight. So I answered that in our case, we can do it thanks to the fusion of the sensors. We do a fusion of the point cloud, And this way we're able to track the same vehicle from one sensor to another.
Yeah.
Clear enough, but yeah, the answer is yes.
So I think we've worked on the questions. So this was our first joint PARIFEX Velodyne webinar. Cool. So in case of any further questions, please do not hesitate to contact us anytime. Please reach out either to Velodyne or to PARIFEX. You see here our contact data, and we have listed additional persons from our organizations. So this is it, and all that is left to do. First of all, a big thank you to you, Nathalie.
Thank you to you, Dieter, for organizing.
Yeah, I think we can do it more often. So I really enjoyed the opportunity to conduct this webinar with you. And thanks to everybody. Thank you for joining this webinar.
Yeah, thanks a lot to everybody.
Yeah, we really do hope that we could meet your
Please do not
your
hesitate.
expectations. And we would be glad if some of you get back to us for further discussion. Okay, guys, thank you. Thank you. Stay healthy in these difficult times. Bye to all of you.
Yeah, take care.